The rare and remarkable moment has finally arrived. The mysterious object known as 3I Atlas has just swept past Mars, a silent traveler from the depths of interstellar space, now threading its way through our solar system. As of October 4th, 2025, this enigmatic body drifts away from its closest approach to the red planet, but it remains close enough to matter, close enough to send shockwaves through the scientific community. Just one day earlier, on October 3rd, it passed its nearest point of Mars, though from Earth, direct imaging is almost impossible. The region where it moves lies buried behind the sun's blinding glare, making ground-based observations futile. Only the silent eyes of robotic spacecraft orbiting and roving on Mars can still see it. Yet, at the very moment we need the most, many of NASA's official feeds and websites have gone quiet. The result of a U.S. government shutdown. Public data streams have gone dark, leaving researchers and citizens alike frustrated and suspicious. It feels almost too convenient that during one of the most extraordinary interstellar encounters ever witnessed, our main line to space has gone offline. Around the world, scientists, amateur astronomers, and even conspiracy theorists are asking the same question. What are we not being told about 3I Atlas? But the silence hasn't stopped discovery. On October 2nd, just days before closest approach, the Perseverance rover on Mars captured something extraordinary, a faint streak across several minutes of sky exposure. At first glance, it seemed like a glitch or stray reflection, but further review proved otherwise. The streak didn't match the motion of background stars or the usual rotational trails of Mars sky. It was slanted, consistent across frames, and unmistakably real. What Perseverance caught was a fast-moving object, quite possibly 3I Atlas itself, crossing the Martian heavens. Credit for spotting this anomaly goes to a sharp-eyed astronomer named Drew, whose post on social media set off a wave of reanalysis. Since then, debate has intensified. How large is this object? What is it made of? And why does it move the way it does? Preliminary estimates suggest a diameter of around 5 kilometers, possibly more, a dense, massive body unlike the lightweight, dusty comets we're used to. Unlike typical comets with bright, sweeping tails, 3I Atlas was a veiled, diffused ionized gas, a ghostly shroud rather than a sparkling plume. Its measured velocity is breathtaking, about 60 kilometers per second, accelerating to nearly 68 kilometers per second as it races toward perihelion, its closest point to the sun, later this October. Something happened on September 25th that may have changed its course. A powerful coronal mass ejection, a storm of solar plasma, slammed into the object. For a moment, astronomers feared the blast might shatter it. But when images came in from September 27th and October 2nd, the object appeared unchanged, stable, intact, but subtly expanding. There was no catastrophic breakup, no fiery explosion, just a mysterious halo swelling ever so slightly, as if energized rather than damaged. And then came the blackout. NASA's social media channels went dark. Live tracking dashboards stalled. For ordinary sky watchers, 3I Atlas simply disappeared. The timing couldn't have been worse, or, as some whisper, more deliberate. Thankfully, the world does not depend on one agency alone. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter have been perfectly positioned to watch the event. Both captured precious spectral data, the chemical signatures of gas, dust, and plasma streaming from the interstellar traveler. And as 3I Atlas continues its journey inward, the JUICE mission, en route to Jupiter, is scheduled to intercept and observe it again. Unfortunately, the sun's interference will delay much of that data until later this year. Still, the combined efforts of these international missions may yet uncover the truth, the first true portrait of an interstellar visitor passing near a living world. So how big is 3I Atlas really? Measuring the size of a comet sounds simple, but it's one of astronomy's greatest challenges. What we see is not a solid rock, but glowing cloud, a mixture of ice, dust, and vapor. The nucleus, the solid heart, is often hidden beneath kilometers of hazy coma. As sunlight warms the comet, frozen ice is sublimate, turning straight into gas, and jets of material burst outward, creating an illusion of size and brightness. To know its true scale, astronomers must separate that glow from the solid core itself. That's exactly what a team from Harvard, led by Richard Kluta, Avi Loeb, and Peter Vess, has been doing. They analyzed data from 227 observatories worldwide, collected between May 15th and September 23rd, compiled by the Minor Planet Center. They compared 3I Atlas's actual motion with the path it should have taken if only gravity influenced it. The difference, though minuscule, a push of less than 15 meters per day squared, held a key clue. Typical comets show stronger deviations because their jets of gas act like miniature rocket engines, gently nudging them off course. But 3I Atlas barely budged. This means it's heavy, far too massive for its outgassing to change its trajectory significantly. From this, the team estimated its mass at over 33 billion tons, and its nucleus about 5 kilometers across. That's several thousand times more massive than either of the two previous interstellar visitors, Oumuamua and Borisov. Avi Loeb, always one to challenge convention, points out that statistically, this doesn't make sense. If the interstellar medium were full of random debris, we should have encountered many smaller visitors long before something this large. Instead, we've seen only 3, and the latest one is by far the biggest. Loeb suggests that 3I Atlas might be a deliberate outlier, perhaps even technological in origin. He points to its unusual mass, its precise trajectory alignment, and even a strange detection of nickel without iron, a ratio not common in natural comets. These, he says, are hints, not proof, but hints, that something extraordinary might be at play. NASA scientists, however, remain cautious. Most insist the object is natural, a comet, albeit an unusually massive and ancient one. From what we've seen, said one mission scientist, this object is active. There's a coma around it. It's almost certainly a comet. But others, like Dr. Suzanne Feiner, have taken the discussion in a completely different direction. For her, the question isn't what 3I Atlas is. It's why it's here. Feiner's idea is bold, even poetic. She believes interstellar objects like 3I Atlas might be the seeds of new worlds. To understand her theory, imagine a young star surrounded by a swirling disk of gas and dust. In that chaotic nursery, tiny particles collide and stick, forming pebbles, then boulders, then protoplanets. But there's a problem. These disks don't last long, maybe a few million years before stellar winds blow the gas away. That's often not enough time to build massive planets like Jupiter or Saturn from scratch. Feiner proposes a shortcut. Suppose an interstellar body, already large and solid, falls into that disk. Suddenly, the system has a ready-made core, a seat around which gas and dust can quickly gather. Planet formation could leap forward in an instant. Her simulation suggests that larger stars, which have more gravitational reach, capture such objects more easily, and indeed, massive planets are more common around massive stars. The correlation is striking. If she's right, then interstellar wanderers like Oumuamua, Borisov, and now 3I Atlas aren't just visitors. They're planet makers, ancient messengers that may have helped build worlds across the galaxy. Some may have seeded gas giants in distant systems. Others might even have sparked the early growth of planets in our own solar system. It's a breathtaking concept that life itself may owe its existence to travelers from other stars. Yet it remains unproven. Interstellar objects are fleeting guests. They appear without warning, move too fast to chase, and vanish back into the dark before we can truly understand them. But this time it's different. 3I Atlas was spotted early. We have telescopes, rovers, and orbiters ready. For the first time in human history, we might finally learn the truth before the visitor is gone. But as 3I Atlas drifts closer to the sun, new mysteries begin to unfold. Deep space monitoring stations have picked up something strange. Faint bursts of radioactivity in the same region of space where the comet's path intersects the solar wind. At first, they were dismissed as background interference, but the bursts kept repeating at regular intervals, like a coded pulse buried in cosmic noise. It's too early to claim anything extraordinary, but researchers note that the signals coincide with fluctuations in the comet's ionized coma, as if the object itself is reacting to changes in solar energy. Some call it coincidence. Others, including a handful of independent radio astronomers, suspect that what we're seeing is more than just chemistry. its behavior. Of course, speculation runs wild online. Some believe it's a kind of beacon, perhaps a long dormant probe that activates only when near a star. Others argue that such ideas stretch beyond reason, that this is simply the natural result of charged particles interacting with a magnetic field. Yet, even among the cautious, one question keeps surfacing. Why now? Why? In the narrow window of 2025, amid unprecedented solar activity, rising global tension, and a worldwide fascination with the unknown, does an interstellar object appear again, this time larger and more complex than ever before. In just over a decade, humanity has gone from seeing none of these objects to witnessing three, each stranger than the last. Oumuamua, the silent, tumbling shard that reflected light like metal. Borisov, the first true interstellar comet, fast and furious, but gone too soon. And now, 3I Atlas, massive, glowing, deliberate. Coincidence? Or are we being introduced, step by step, to something the universe wants us to see? NASA and ESA maintain their careful silence, releasing only fragmented data through private channels. But leaks and amateur observations continue to paint a vivid picture. The comet's coma, once diffuse and circular, now shows faint three-lobed structures, giving rise to its haunting nickname, 3I Atlas. Each eye appears as a region of intensified ionization, glowing knots that seem to pulse with rhythmic brightness as the object rotates. The effect is mesmerizing, almost biological, as the object were watching the cosmos around it. As the days pass, sunlight grows stronger, and 3I Atlas responds in ways no one predicted. Instead of breaking apart like ordinary comets, it stabilizes. Its coma becomes more uniform. Spectral readings suggest that heavy elements, nickel, cobalt, even traces of titanium, are concentrated near its surface. This isn't the composition of an icy wanderer. It's closer to a hybrid of metal and mineral, a mix that's difficult to form naturally in the freezing void between stars. Some scientists now propose that 3I Atlas may not be a comet at all, but a fragment of shattered planet from another solar system, the metallic core of a long-dead world, flung into interstellar space billions of years ago. If that's true, then this isn't merely an alien visitor. It's a piece of another world, carrying the chemical fingerprints of a sun we'll never see, from a galaxy we may never reach. Meanwhile, the JUICE mission prepares for its once-in-a-lifetime encounter. As it slingshots past Mars on its way to Jupiter, the probe's instruments activate early, attempting to capture spectral readings of 3I Atlas as it moves sunward. For a brief moment, before it disappears behind solar interference, JUICE's sensors detect something astonishing, a structured emission pattern in ultraviolet light, repeating every 11 minutes. It could be a rotational signal. It could also be something else. No one knows yet, because the data remains partially encrypted until it can be safely transmitted after the sun's interference clears. But already, rumors ripple across scientific networks, whispers of an organized pulse, like a heartbeat, resonating from the interstellar traveler. Whatever the explanation, 3I Atlas is rewriting how we see our place in the universe. It's forcing us to ask new questions. Are interstellar visitors common, and we simply lack the eyes to see them? Could they carry organic materials, or even microstructures that plant the seeds of life when they crash into young planets? Are we, ourselves, the descendants of such cosmic seeds? After all, the atoms in our bodies, carbon, iron, oxygen, were forged in the hearts of long-dead stars. We are, in every sense, children of the cosmos. Perhaps 3I Atlas is only reminding us of that ancient truth, that life doesn't belong to one world alone. When we look at the night sky, we see emptiness. But in that emptiness drifts a billion stories, the debris of creation, the echoes of collisions, the silent witnesses of time. 3I Atlas is one of them, a wanderer crossing the infinite gulf between suns. It carries no message, no language, no intention that we can yet decipher. And yet, its arrival stirs something primal in us. Curiosity, awe, and a deep, wordless connection to the cosmos. In a way, it reminds us of ourselves, small travelers in an endless universe, seeking meaning in the vast dark. as the object approaches its perihelion at the end of October. Telescopes from Earth and Mars will align for one last coordinated attempt to capture its image before it swings behind the sun and vanishes from view. After that, 3i Atlas will be gone, likely forever, racing back into interstellar space at tens of kilometers per second, slipping quietly between the stars. Will we ever know what it truly was? A comet, a fragment, a seed of worlds, or a relic from a civilization older than we can imagine? Maybe not. Maybe it was simply a natural traveler, and the wonder lies not in what it is, but in the fact that we were here, alive, conscious, watching it pass. And as its faint light fades beyond the reach of our instruments, one thought lingers. Perhaps one day, long after we are gone, our own machines, tiny fragments of Earth, carrying our fingerprints and our dreams, will cross another sky, over another world, and someone will wonder who we were.